Hello everyone, and welcome back to exercise number 20 of the SolidWorks Basic Tutorial series. In this video, we're going to be designing a piston cap. Now, what you see here is a typical representation of a piston cap in SolidWorks. This mechanical component can be typically found in pneumatic and hydraulic systems, but most importantly can be found within engine assemblies. Now, of course, in engines, we have the piston cylinder assembly that drives the rotary shaft, which again gives us the power that we need from the engine. This component right here, typically, if it's a single piston cylinder assembly, this is what covers it all. So at the top of the engine, we have a piston cap that covers the piston and allows it to operate. This is typical schematic representation of exercise number 20. We see here that this is the isometric view, this is the top view, and this is the section view. The section view taken along this line. So basically, we cut the component along this line, and then we look at the top right here. And this is what we see. The dimensions are fully defined. But again, please take notes. This is very important that we're dealing with the inches system here. All dimensions are in inches. So again, we're not dealing with millimeters, we're dealing with inches. So yeah, with that aside, let's get started. So let's go ahead and close this. Create a new SolidWorks part. We set the background to plain white, and we copy exercise number 20 into SolidWorks. Before we actually begin the modeling process, again, I need to remind you that we're dealing with inches here. So before we begin, we go down here, and we change the unit system within SolidWorks. Currently, it's in the millimeter, gram, second system. We're going to select inch, pound, and second system for this exercise. So go ahead and select that. Now, whatever line, circle, or geometry we draw, the dimensions are automatically going to be in inches. All right, so looking at the schematic right here, we see that the piston cap has an overall geometry of a cylinder, right? And then we have details within the component itself. So let's go ahead and select top plane, sketch, and draw a single circle. We're going to begin by modeling the overall cylindrical profile of the piston cap. Go to Smart Dimensions, and looking at the schematic here, we see that the piston cap has an overall circular diameter of 5.75. So let's go ahead and assign a diameter of 5.75. Now go to Features, Extrude Boss Base. Now we're going to extrude this circle profile to create the thickness of the piston cap. In this case, looking at the schematic, it is 1.5 millimeters. So assign a thickness of 1.5. Select OK. Now we're going to create the openings here at the center of the component. So select this face, sketch, go to Circle, and draw one smaller circle. Go to Smart Dimensions, and to create the opening here within the component, we see that we have a smaller circle with a radius of 2.56 inches. So this has a diameter of 2.56 times 2, right? Now we're going to cut this circle profile to a depth of 1.19 to create the opening. So go to Features, Extrude Cut, and we're going to create a cut with a depth of 1.19 inches. Select OK. Next step is to create the opening here at the bottom. So select this face, sketch, go to Circle, and draw a single circle. Go to Smart Dimensions, and looking at the figure, we see that the circular opening at the bottom has a diameter of 3.38. So let's assign a diameter of 3.38 inches. Select OK. Go to Features again, Extrude Cut, and this circular profile, this hole cuts all the way through the component. See, if you look at the isometric view, there's a hole that cuts all the way through. So select OK. Now we're going to work on creating these 8 holes to the sides, the periphery of the piston cap. Go ahead and select this face, sketch. But before we actually draw the holes, we see that there's a construction geometry circle, which pretty much gives you an indication of how far these holes are from the center of the component. So let's go ahead and select circle and draw a single circle. Go to Smart Dimensions, and this construction circle, this construction geometry has a radius of 2.13. So this should have a diameter of 2.13 times 2, which gives us 4.26 inches. Now again, this is a construction geometry. So go ahead and select the circle and go and select construction geometry. We're going to convert this circle into a construction geometry. Now again, select circle and draw a single circle like so. Assign a dimension, the dimension or how large these holes are. They should be 0.44 millimeters. So this has a diameter of 0.44 inches, sorry. So not used to the inch system. So 0.44 inches. To repeat these circles along this construction circle right here, what should we do? We first of all should select the circle, go to Linear Sketch Pattern, and select Circular Sketch Pattern. All right. Now, the dialog box is going to ask us to assign the number of holes that we're going to create. In this case, they're 8 in number. So select write 8 and select OK. Now we have 8 equally distant circular profiles. Go to Features, Extrude Cut. Again, these are holes, and these holes go all the way through the component. Select OK. See, we created the holes along the periphery of the construction geometry. Finally, we're going to work on these flanged lugs. Basically, they're like arms for the bolts to go in and hold the piston cap assembly in place during operation. So go ahead and select this face, sketch. Looking at the figure here, we have one larger circle and then another smaller circle, right? So what do? We go ahead and select circle, and we construct a circle up to this center point right here. We select the circle and convert it into a geometry. We go to circle again, and we draw one larger circle. And this larger circle should have a radius of 0.44. So it has a diameter of 0.88. All right. Select this circle and go to Convert Entities. Select Convert Entities. Now let's go to Line, and now we're going to close off. We'll create the profile of this flanged lug. So go ahead and select this point all the way to the end here. Go select Line again. All right. Go to Trim Entities and trim any excess curves or lines we have. Now go to Features, Extrude Boss Base, and go ahead and select this sketch. Reverse direction, and we're going to extrude this profile to a thickness of 0.31. So this should have a thickness of 0.31 inches. Select OK. Now to repeat this pattern, once again, go to Linear Pattern and select Circular Pattern. Now it's asking for the direction. within the dialog box. So the direction of this circular pattern should be this circle. And the features or faces to create the circular pattern, we select, let's go ahead and select this curve selection, this curved surface right here. Right. So again, they're looking at the figure here. We see that they are 4 in number, and automatically we've selected 4. So select OK. Now we're going to create the holes within the flange lugs itself. So select this face, sketch, go to circle, and draw 4 circles. Of course, you can use the circular sketch pattern feature for this. Either way, it makes no difference. So there are 4 numbers, so that it's not that time wasting. Go to Smart Dimensions, and this has a radius of 0.44 inches. 0.44. And 0.44 as well. Go to Features, Extrude Cut. We're going to cut this all the way to the other side right here. Select OK. Go ahead and delete the image. Set to perspective. Let's assign the material. Select polished steel and select OK. All right, so that concludes exercise number 20. I hope you have all enjoyed this video. If you have any comments or suggestions, please let me know down in the comment section below. Don't forget to like and subscribe to the channel. I'll see you all in exercise number 21. Until then, bye-bye.